Hello, geometry. Here we are with 7.2, similar polygons. So what does it mean for polygons to be similar? We've been so focused on the word congruent, and congruent means to have the same shape and the same size. But similar, they're just going to have the same, they're going to have the same shape, but different sizes. Basically, and the symbol for similarity, the symbol is this squiggly. It's like the squiggly that's above the equal mark on congruence. Basically, it's just a shape has been enlarged or a shape has been reduced, scaled up or scaled down. Then they're said to be similar. Same shape, different size. Okay? Basically, we say they're proportional. We'll get to that. So, two polygons are similar if these two relationships are in place. Corresponding angles are congruent. Okay, so just like a square, you can have, squares are similar. You can have a small square, a large square, and they both all the angles are 90 degrees. So the angles can be congruent in a similar figure. But the length of the corresponding sides are not necessarily congruent, but they have to have a relationship, and we say that they are proportional. Okay, so they're scaled up or down in the same way. And how they're scaled up or scaled down is this ratio. Okay, and so a ratio is just a fraction that compares two numbers. And so that ratio of how A, B, C, D goes to E, F, G, H, how it got enlarged is called a scale. That ratio is called a scale factor. Okay, sometimes it's called a side ratio, but mostly it's a scale factor. All right. So basically, these guys are similar. Let's say that these are similar. If so, then the angles are congruent. So A is congruent to E, B is congruent to F, C is congruent to G, and D is congruent to H. Okay? And then to show proportionality, remember from 7.1, proportions, a proportion sets two ratios equal. And then again, a ratio is a fraction. So to show proportionality, I've got to set all these fractions equal to each of all the sides. So AB to EF, BC to FG, CD to GH, and DA to HE. Okay, so that's how you show. The criteria, number 1 and number 2. This shows congruence. This shows proportionality. All right. So complete the statement. If this four-sided figure is similar, there's your similarity mark to this four-sided figure, then C, who's secondly listed here, is going to be congruent. Angles are going to be congruent. So C, who is listed second, is going to be with K, who's listed secondly here. RT, so R is the fourth letter to the second. That's going to have to be proportional. So a ratio RT to DQ. Just, tracking correctly, RT, DQ, and then VT to LQ. Those ratios will have to be equal. They'll be different numbers, but they'll have to reduce to be the same scale factor. And then another angle congruency from a similar triangle. J is going to be congruent to G. They are both in that corresponding position right here. All right, let's compute some scale factors. If you want, you can rearrange this triangle here so it's sitting the same as the other. It's smaller, but let's just put it in the same position here. So this would be F, this would be H, and this would be G. Okay, and so we've got some numbers here. This is 15, this is 17, and this is 8. And so we're just going to see what the scale factor is. So it does say to go to larger to smaller, so I'm going to go this direction, larger to smaller. So 24 is to 8, as 51 is to 17. In order for these to be similar, these have to reduce to be the same. And sure enough, they are 3 to 1, 3 to 1. So that scale factor is 3 to 1. So I wrote the larger one first because it told me to. Okay, and so the similarity statement, just get them in order. GFH is similar to XWY. So I just went GFH, XWY. And there's a similarity mark, right? The next one here, these look like rectangles because I have the 490 degrees, but the sides are the same, so they're not squares, but they have to be rectangles. So 35, 9, 25, 25, and 6. So they're in the right position because the longer side is here and the shorter side's here. So 35 is to 25 as 9 is to 6. Those have to reduce to be the same, and it looks like we have an issue. These are not similar. The scale factor is not the same, so that might happen that they're not similar. They're both rectangles, but they're just not proportional. One might be a little, wider. One might be a little more narrow, but they're just not a enlargement or a reduction of one another. Okay, number 6 tells us that we do have similar figures, and looks like they're in the same position, so that's easy. So 19 goes with X, 24 goes with Y. 12 goes with 6. That's going to be important here because this is going to reveal the scale factor. You have to have something that's known to get the scale factor. Where was I? So 19 is to Z, and we're done. So the scale factor here then is going to be 2 to 1. So, that just means that this has been reduced by 2. So we can obviously do that in our heads, but just to show the math, you would say 19 is to X as 2 is to 1. So 2X equals 19, X is 9.5. And that's just 19 cut in half because of that 2 to 1. All right, and 24 is to Y as 2 is to 1. 2Y is 24, and Y certainly comes out to be 12. Which makes sense. That's half, that's half, that's half, and we've already done Z. We've already done that math. That will be 9.5 as well. All right, so Z is 9.5 as well. All right, to the back. If I can flip my paper. Okay, in the diagram below, we have a similarity statement. They are similar. So let's find the scale factor, measure of D, R, and DE. All right, so I'm just going to poke around over here. I like how it's given to me organized, so I can just figure this out. So I know 89 is Q, and Q goes with F, so I can put 89 here. That's easy. E is 35, and E goes with R, so I can put 35 here. That answers one of my questions. Okay, and the other one, we're bound by the triangle sum theorem. So 180 minus 89 minus 35 is 56. That's D. So the angles are easy. Angles are working just like congruency. And as for the scale factor, let's see. So I've got 40 and 36 and 20. And, I don't know who goes with who just by looking at it. But only one I know here is DF. So DF is 24. So DF is going to be involved. We'll just wait here. So DF is this first, and this, DF is going to be corresponding with PQ. And PQ is 20. So 20 and 24 are the sides that I want to link. And it's telling me to map the smaller to the larger. So smaller to larger. So I'm going to give the scale factor then in that same order. Small to large, so 20 to 24, which reduces to 4. 4 goes into 25 times, and 4 goes into 24 6 times. This is 5 over 6. So let's find DE. Okay, so DE is the larger here, so we'll just do 5 over 6. DE is going to, DE is going to correspond to PR, and PR is 40. Okay, so PR is 40. That's going to be 40, and this is going to be this DE. I'm going to put an X there because that's just easier than writing DE, so hope that's okay. I'm just going to fill that blank with an X. All right, so cross multiply, 5x equals 240. Divide by 5, and x, which is DE, is going to be equal to 58. Okay, so we're going to get 58. Why can't I divide my 5s and 4s into 20 correctly today? 5 goes into 24 times, and then that's 48. All right, so DE is 48. All right, so that's DE. Okay, additional practice. Scale building. A scale of building A needs to be made using a scale of 1 inch to 190. How tall will the actual building be in the scale drawing if the building is to be 1330 feet tall? Okay, so let's see. So we have the scale is 1 inch is 190. How tall will the building in the scale drawing be if the actual building, there we go, the actual building is 1330 feet tall. All right, so this is like if you have a map and you have some equivalencies there. So this is a very common type question. You might think that you have to convert. If you're just doing a ratio like 1 to 190, you would have to convert those to the same units. But with a proportion, you don't. That's one thing that I need to point out, because in 7.1 we did all that conversion, right? But we were just analyzing single ratios. When you have a proportion, you don't need to convert. You don't need to convert for proportions. So I would just say 1 inch is to 190 feet. So, this is the model. And this is the actual. So, and this is how many inches if the actual building is 1,330 feet. All right, so we multiply 1330 times 190x, divide by 190, and this comes out to 7. So the scale drawing, which is kind of like a model, would need to be 7 inches to represent the actual building of 1330. All right, so last little problem here. Let's read it out. The space allowed for the mascot on a school's web page is 128 by 80. So let's see, we have some web page here. I don't know. It's a web page. I always like to draw a diagram just to get my head around problems. 128 pixels by 80 pixels. All right, the digital image is bigger. So the digital image, there's this mascot. This is the digital. 600 by 375. Those are pixels. Okay, so we got to shrink this down and see what I can get on the web page. So we're going to kind of see if this proportionalizes down. If it does, great. That problem's easy. If not, we'd have to scale it down slowly until we got to something that would fit, but not, that the first time it would fit. But first, let's just see if it's proportional, because if it's proportional, then this problem's super easy. So let's see, we got 80 over 128. Let's see if that is equal to 375 over 600. So if they have the same scale factor, that's just straight reduction. Okay, so I don't know. Let's reduce this to 40 over 64, 20 over 32. I'm going to get my division right here with the 4s and the 5s. 4 goes into 20 5 times, and 4 goes into 32 8 times. So this is this is a 5 to 8. And let's just see if this is the same here. So what are we going to do here? By maybe 25 would go into there 15 times, and 25 would go into here 24 times, and then 3 goes into there 5 and 8. So they have the same. And I could have done this also Typically you go, image to image, but you can proportionalize within the image. So if I had done 80 is to 375 as 128 is to 600, that would have worked also. Okay, 80 would have you would have been able to proportionalize this the same too. But this is easy. So check, it's going to fit perfectly. It's just going to scale down, and the largest image that will fit, as we shrink it down, it'll fit the web page perfectly. So 80 by 128 pixels. And helpful hint, I think all problems on Math Excel, I think I tested a bunch of them way back when I was creating this homework assignment. I think they all turn out to be perfect scale factors, just FYI. I may be wrong, but I think they do. Anyway, all right, good luck, everybody. See you soon. Bye.